There's a nice study published last year in Agricultural Systems, Neumann et al., a group from the Netherlands, and they do frontier production function estimation, and they try to explain deviations from that frontier with variables like irrigation, market influence, accessibility. So a bit crude, but nonetheless, if you look at their study, it really highlights the economic variables in this. So it does seem like there's enough biophysical potential out there. The question is, can it be achieved? And that's a question of economics, and we really just rediscovered Bob Hurt's study of 30 years ago for Erie, looking at yield gaps, where he talked about the dramatic difference between what's technically possible and what's been achieved, and identifies this very comprehensive study. He really fingers economics as the main reason that part of southern Eastern Africa, for example, they're paying high prices for fertilizer inputs. They're getting low prices for their output. It's not surprising that agriculture is not very intensive there. So that's the demand side. We want to shift to the supply side now. And the first thing is urbanization. Okay, this is a movie of urbanization over the last 50 years. And you can see that cities with more than 5 million are growing. Boy, if we look at South Asia and China, lots of red circles, Western Europe, northeastern US, and we see Melbourne and Sydney on there as well. That's reassuring. Most of the growth in the next 50 years is going to be in developing country urban areas. So watch where the red circles accumulate now. South Asia and China, you can't hardly think there could be more circles in there, but it's getting redder and redder. In other parts of the world, increases, but not so much. I think the message here is that if you do the numbers globally, urbanization isn't going to be a big player. But regionally, if you look at South Asia and China, and that was also the conclusion that Derek Byerly reached in the World Development Report, that those are the regions where urbanization is likely to have an impact on agricultural land availability. Something that hasn't received as much discussion that I think is a really interesting thing and be fun to try to quantify it, is the demand for land set aside for environmental purposes. There are some regularities that the forest economists have identified. This graph shows France over 500 years, the forest cover. For a long time, they cut down their forests. And they reached some point in the middle 1800s where they started reforesting. That phenomenon has been studied by Kauppi et al. In one of the references worldwide, and they've looked not just at forest cover, forest density of carbon, okay? So they look at the total forest carbon stock. So you can either have more forest or older forests in order to accumulate carbon. And virtually all of the countries above 4,600 per capita are accumulating forest carbon. So as the world becomes richer, as we move through that income distribution moves across that line, we're talking about more and more. This is a proxy for many environmental services coming from this forest land, not just for, in fact, not forest, largely forest carbon sequestration. That's in addition. Setting aside this land is a source of conflict. We can see that. The protests in Thailand a year ago, one of the key objections of the rural population demonstrating in Bangkok was that a whole bunch of land in northeastern Thailand was set aside for ecotourism and environmental purposes. That was in direct conflict with their interests in agriculture and forestry. This is an important element of this long-run picture that hasn't been well fleshed out. Climate change will also alter the effective supply of land to agriculture. This is really complex. I'd say IFPRI and YASA have been the ones who've examined it in a comprehensive way most extensively, the impacts on agriculture. IFPRI highlights the impacts in South Asia. YASA, Gunter Fischer, highlights Southern Africa. Schleicher and Lobel have a recent paper in Environmental Research Letters focusing on Sub-Saharan Africa. Their rule of thumb, well, David Lobel's rule of thumb in my conversations with him is that 1 degree Celsius rise for Africa is going to translate into a setback of about 5 years trend yield growth. So that delta on the trend yield growth is not exogenous. It's going to depend on what happens to climate. David and I have worked on a paper with a nearer term time frame of 2030. We were looking at poverty impacts of climate change transmitted through agriculture. He put together for that a distribution, an idea of a distribution of outcomes, and he's tried to factor into that uncertainty about coming out of the climate models, uncertainty translating those climate outcomes into agricultural outcomes, the full range of biophysical uncertainty underpinning its estimates. These are his worst case scenarios for 2030. This is built up from both econometric work and biophysical modeling, as well as the full suite of climate models being used. And you can see, in the worst case scenario, the US maize production, this is just at the national scale, or even a regional scale, so I apologize for this was what we were using in the simulation. In his view, and this is underscored by his more recent work with Schlenker, there's a threshold with maize currently where you start exceeding 30 degrees Celsius and you start experiencing some very sharp drops in yields, and that's based on econometric work done in the Corn Belt. And that's evidenced in this worst case scenario. What if we're all too optimistic? On the other hand, there's the expected outcome, pretty more modest. His whole point is that we shouldn't just look at the expected outcome. It's often kind of uninteresting. And there's a possibility that we're all being too pessimistic. Okay? You got to acknowledge that. And in fact, there can be benefits. If the temperature impacts are less severe, precipitation actually increases in some of the key regions and so on. So we've taken that kind of view of the world, and we've then put this in an economic model to model the impacts on economic variables. And even though, according to this bar chart, the distribution for wheat, rye, oilseeds, and coarse grains, in most places around the world, we can't say with certainty whether yields are going to go up or down, yields in a biophysical sense. So the red bars are low, red bars denoting in the bar chart the percent of the sample, the simulation sample, that's significantly different from zero. We really can't say whether the biophysical outcome, we can't sign that, but we can sign the economic outcome, which is kind of odd. You might have thought, well, once you put this in an economic model, it's going to become even more uncertain. But the reason is that the economic outcome depends on the relative sizes of these shocks. Southern Africa always gets hit harder than other regions for a given crop. Maize in North America often hit harder. The economic response depends on the relative magnitudes, and the relative and these shocks determine then relative prices. Relative prices determine exports and output. So if you plot these changes in exports and changes in the crop price supplied from a given region relative to the world average export price index, the results are much more robust, and that's what's giving us this. So it's kind of interesting that even though it turns what you thought on the head, even though the climate scientists can't tell us with certainty what's going to happen to yields, maybe the economists can say something meaningful and useful, especially about the agricultural impacts. Coming close to the end here, John, I want to say briefly, and there's been a lot of great papers here. I really appreciate it. One of the things I've liked most about this conference is the papers dealing with this difficult issue of mitigation opportunities in agriculture and forestry. Our work suggests that, and this is global, very simplistic global stuff, that while agriculture, forestry, land use change combined account for about 30% of greenhouse gas emissions, we estimate that they could supply, in a perfect world, okay, up to 50% of the efficient abatement, $27 per ton CO2e. So there's a lot of potential there. That point's been made many times here. But what impact does this have on agriculture and food prices? McCarl, in an analysis done in 2009, at the time the U.S. was seriously considering climate legislation, said this could lead, in his model, running that legislation through the model, this could lead to a loss of 50 million acres of cropland to forest sequestration in the U.S., and thereby leading to a doubling of U.S. corn prices relative to the baseline. That was pretty dramatic. Riley et al. Are even more dramatic in their estimates, more longer-term estimates, the impact on food prices of serious land-based sequestration. So my hypothesis is that in the next 50 years, I'm talking 2050, that the impacts on agriculture of our attempts to mitigate climate change are going to be more important for agriculture than the impacts of climate change on agriculture themselves. So that's an interesting hypothesis. Water, I can't finish the talk without saying something about water because that's been a big topic here, and I know you're all keen on water. All the water sessions are very full. I just want to say that it's not just Australia where irrigation is important. Worldwide, 40% and 42% of global crop production is from irrigated agriculture. So it's much less the area, but the yields are much higher. This accounts for 70% of global freshwater withdrawals. Any pressure on water is pressure on irrigated agriculture. Any pressure on irrigated agriculture is pressure on global output, means higher prices. McKinsey et al. Have a very simplistic study of global water that you drew heavily on the impact water model at IFPRI, and they estimate just some attention-grabbing numbers globally. At current efficiency, water demand will exceed existing sustainable, reliable supplies by 40% in 2030. 1/3 of the world's population in 2030 will live in river basins with a water gap more than 50%. That's assuming current efficiency. Obviously, things are going to change. We're seeing it in Australia. You're at the forefront here, but we're going to see it elsewhere around the world, and it's going to have an impact on this story. So I'm wrapping up now. Critical assessment. So things to keep your eye on. 6 factors, 3 exogenous shocks that have received lots of attention, and 3 economic responses or elasticities that have received less attention. I think the work to date has erred in 2 ways. Too much has been thrust into the exogenous components. Biofuel demand growth, we can see it depends entirely on oil prices as well as feedstock pricing. Yield growth, trend yield growth, going on forever regardless of R&D that's been made historically, regardless of any turndowns Phil made and Julian may have identified in R&D investment. So those are exogenous trends. The elasticity, the other complaint I have is the elasticities used in the model aren't long-run elasticities. And Jerry Nelson and Mark Rosebrandt have graciously iterated with me so I could do a simple calculation. If you solve this model instead of land use, you solve for price. And you look at a couple of these, the most influential studies from YASA and IFPRI. And these aren't the most up-to-date studies, but they're reasonably recent. I can get from those studies the deltas with some help. That's from Jerry and the research assistant there, and I can get the prices. So I can solve for eta, which is the sum of these economic responses, and I get a number that's typically less than 0.5 for the sum of all these margins. Well, just think back to the demand elasticity I was showing you, the long-run demand elasticity in response to cross-country differences in prices. Add in, this potential for higher prices to drive R&D, to drive yields, and so on. It seems like the numbers that we're using there are excessively influenced by things like the last commodity price crisis, which, any reasonable model should be able to replicate that. But replicating that, my argument is a totally different mindset than thinking about climate impacts in 2050. So I think those studies are overstating the price impacts for that reason, and the land use impacts. More critical assessment in terms of policy recommendations, to the extent that there's any policy relevance in this talk. It's all about these elasticities. So make the elasticities big, avoid things that make them small. Okay? So effectively functioning international trading system, that's a way to make the elasticities in any given region large, right? Because you may have a shortfall in your region, but if you can import from the rest of the world, and that's going to enhance the demand elasticity. The shock absorber effect is going to reduce the impact, the pressure on land use in that particular region, or the pressure on prices. Unfortunately, as Kim and Will have identified, the trading system is not functioning in that way, and is rather exacerbating these crises. Avoid inflexible environmental mandates. The worst one in my mind is the U.S. corn ethanol mandate. Thou shalt send 15 billion gallons, produce 15 billion gallons of corn ethanol come hell or high water, okay? Just doesn't make sense. It exacerbates volatility, as I was indicating before, exacerbates the land use impacts and so on.